I'm going to use the interquartile range to identify any potential outliers for my heart rate data set that I've been working with. So the interquartile range method is where we take the interquartile range and add and subtract 1.5 times that interquartile range from the first quartile and the third quartile. So for a lower outlier, I'm going to take the first quartile and subtract 1.5 times the IQR. So for my previous example, I found the quartiles, and for this I just need the first and third. The first quartile is 76.5, and I'm going to subtract 1.5 times 7.5. Okay? So 1.5 times 7.5 is 11.25. So taking 76.5 and subtracting 11.25, I get, using my calculator, whoops. Okay, sorry about that. I get 62.25. So if there are any values below this in our data set, we can consider that an outlier using this method. There are other ways to identify outliers, but this is a very simple way to do so. To identify any upper outliers, I'm going to take the third quartile, Q3, and add 1.5 times that interquartile range. So the third quartile for this data set was 84, and I'm going to add 11.25 because that's 1.5 times 7.5. Okay, so doing that, I will get 95.25. So any data point that is above 95.25 would be considered an outlier. So looking at my data set using this method, I do have one value that is below 62.25. Okay, just barely though. So this first data point of 62 would be considered an outlier. And then scrolling down to the bottom of my data set, any values above 95.25 would be considered an outlier on the upper end using this method. So I do have one data point that is an outlier, and that would be this 98 for a heart rate.